Hello, I'm Gavin Knight from Mystic Pants. We're an IoT design house. We specialise in device design services, prototyping, board design, application software design, back-end firmware, and also the device management services that you need to make the product a success for your customer through our connector platform. Some of you will know me from other videos where I've talked about ESP8266 and hologram and Sigfox, but today we're going to be concentrating on the Electric Imp side of the business, and we're going to do that here at IED in Santa Ana in California. IED are a partner of ours and we're working with them here. They're a contract manufacturer. Together we've been producing a new device for a new customer, and the exciting thing about it is that we've produced nearly 10,000 devices in just 10 weeks, 8 weeks, actually it is only 8 weeks, which is an order of magnitude faster than I've seen anyone else get their product into the marketplace before. And a lot of that comes down to a combination of excellent design, which is done by some of our partners as well as by us, and the fantastic facilities that these guys have here at IED with their high-speed pick-and-place line and their automatic inspection services, and of course the Electric Imp platform, which is fantastic for this kind of deployment. So I'd like to take you inside now. I've got my checklist and take you through all the stuff that I want to show you, talk to you a little bit about Electric Imp. So let's go do that now. Okay, so welcome to the factory here at IED. It's a typical contract manufacturing facility. We have 3 high-speed surface mount integrated production lines. We have a screen print machine here, and then we move through to a pick and place machine for the first batch of components, and then a second one because it's too much to get from 2 sets of reels, so they need 3 sets of reels. I think this machine can do something like, with two sets of reels, can do something like 78,000 components an hour. So it's pretty high speed, and they're just about to put in another identical Samsung run. Then they go to the oven and they get baked, and then they'll go to be washed and inspected using the automatic optical inspection equipment and X-ray. Now I'm going to take you through to where it changes, because up till now this is regular contract manufacturer stuff. If you were going to put a pick on the board, for example, you'd have that pick pre-programmed and it would go on here as a component with the software already installed on it, the embedded code, no matter what sort of MCU you're using. But with a lot of IoT devices, it's a little different because they're over-the-air updatable, which is of course one of the fantastic things about them. So here we have a commissioning line that lets us connect each of these boards to the internet for the first time so that it can download fresh code and be prepared for deployment to the customer. So just through this way, this equipment came from Electric Imp, and some of it's been custom manufactured here locally to suit the particular batch production requirements that we have here. So we've got a load of work in progress up here, and we need 8 lines to be able to get it through quickly so we can get everything done in a relatively short period of time. So for me to handle the boards, I'll need to be anti-static, so I'll go and change, and then we can come back and I can show you how one of these units actually works, and the commissioning process, the blessing process, and the testing process for Electric Imp functions. Alrighty, so here we are. I've changed into a new suit so I can comply with the electrostatic requirements of the factory, and we're here on the pre-commissioning line. I'm just going to take you through the reasons why you would want to use this sort of process and then exactly how the process works. So why would you want to go to this trouble? Right? Typically you could write the firmware onto a chip, get it put on in the pick and place machine, and then you're done. The problem with that is if there's a problem in the firmware with IoT devices, that is much more likely because we're looking at much more complex software, then you're not going to be able to easily recall that device, you're not going to be able to easily update the device. So by carrying out this pre-commissioning step and by using a platform like Electric Imp, then we're actually able to ensure that we have the capacity for OTA on the device before it ships. And we're also able to ensure that we have good security both for communications and the code, because this process of blessing the device with the Electric Imp cloud will secure those things for us. So I'm just going to go ahead and show you how the actual process functions. We have a board. I'm going to reset the board and blink it up. So at this time, then we're blinking up the device. It's transferring the access point and the password details from the station to the device which is under test. That device will then connect and it'll get the factory code, so the code which is used to test everything about the device. So it's going to connect to Electric Imp, and Station 5 is going to phone home. Station 5 is unique to Electric Imp, and the individual device is unique, so we can kind of secure everything along the whole supply chain. Right, so we're testing the device. Some automated tests are going to run, and we're going to then confirm that the tests have been completed successfully. Once it's passed, then Electric Imp blesses the device, which locks the device to our account and secures the communication channel between the device and the virtual machine in the cloud. Then we restart the device and hit it with the final production code. So it'll blink up again, and when it comes back this time, the station will ensure that it's loaded with its final production code. The code will be coming from Electric Imp via Wi-Fi. Now when it does that, the last thing it's going to do is print us out a set of labels that are specific to the board. That set of labels is going to allow us to put one label on the board, one label on the outside packaging, one layer on the inside package, one label on the inside packaging, and one layer on the final box. So at any point, we know that we've got the same device and the right device all the way through the supply chain. Now, how these labels really revolutionise ongoing support and maintenance of products in the field is, in this case, we've printed both a QR code and a barcode. The barcode will be used because it's more common in shipping applications, but the QR code actually brings us directly back to this device, and we can see that the device is connected and that it's been tested, and this is where it was originally commissioned, and the tests that were carried out, and a whole bunch of other useful information. And this is not only useful at this time during the production process, but this continues for the life of the device. So if you've got a field agent going out to check on a problem, or a consumer's calling you and asking you to help fix their problem, you can scan the QR code that originally came with the box or that's on the device itself, and you can derive all of that information. If you've got a project that you're looking at that has high security requirements and requires fast turnaround and a high level of certainty, then this is the sort of process that you want to use. It requires a change of thinking in terms of the way contract manufacturers generally do things, but long term it's going to be worthwhile. Thanks very much.